Hi, this is Priyadharshini, working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today, we are going to continue with the next lecture series, that is the steps for designing and analyzing an algorithm. We all know what is an algorithm. So, algorithm is a finite sequence of instructions for solving a particular task. Now, let's continue with the steps for designing and analyzing an algorithm. So initially in algorithm design and analysis process there are crucially 6 steps. So the first step is to understand the problem. The programmer or the program solver should understand keenly what the particular problem is. Then the next step is to decide on the computational means, the algorithm design techniques that is to be used, or for let's say you have to make a decide on what the computational device is, what data structure you are going to use. All this should be decided, and then you have to efficiently design an algorithm. After deciding on the algorithm, its particular data structure used, the algorithm should be proved for its correctness. That is, for any algorithm, for any input you give, the correctness of an algorithm should stand still. After proving the correctness, the next step is to implement the algorithm. Before implementing the algorithm, it should be analyzed for its efficiency. If there is any issues in efficiency, then it should go back to the step 2, that is to decide on to make a decision whether the algorithm's finiteness is proved or not. After checking with the analysis, after checking the efficiency of an algorithm, then lies the final step, that is the coding the algorithm. Let's discuss in detail one by one. So the first step in algorithm design and analysis process is understanding the problem. What do you mean by understanding the problem? So first you have the programmer who is going to build the particular problem's algorithm should clearly read the problem what it is. He should ask questions to clarify his doubts, and then he has to find and decide the range of different inputs for the efficiency of the algorithm to work. The next step is to decide, to make a decision. So to make a decision we have 3 steps. We can further classify the decision making task into to find the computational device, to check the exact or approximate solving, or to design the data structure that is to be implemented. So first we'll see what is a capacity, what is meant by computational means. So computational means can be of a sequential or the parallel computational technique. So for this particular solution or for the particular algorithm, I have to decide whether I am going to take the task in sequential manner or I am going to do it in a parallel task. We all know what is sequential and parallel programming. So I have to first decide on the computational means, whether it is parallel or sequential. After deciding the parallel or sequential technique, the next thing I have to select the problem solving a method, whether I am going to take an exact problem solving, or if I need for some problematic needs, I have only approximate solving methods. For example, if I have to find a square root of an algorithm, I can go only with the approximate solving problem technique. So I have to decide on whether I am going for the exact or the approximate problem solving technique. And finally, the third stage in the decision making process is the design technique, the algorithm design technique. So in this algorithm design technique, I have to stick on to which data structure am I going to use for my computational needs. If I have any old method, I can make use of that. The next step in the algorithm design and analysis process is designing an algorithm. So designing an algorithm can be of 3 ways. The first one is natural language solving method. Second one is pseudocode. Third one is the flowchart. So what does mean by natural language solving? So natural language solving is nothing but whether I am going to write the algorithm in English means itself. That is, if I write the algorithm in my own words, that is, if I use English as my language and I write an algorithm, that is called natural processing method. The next design of an algorithm is using a pseudocode. A pseudocode is nothing but a false set of code, which is actually not just a programming language. It just gives in a pseudocode of what, for example, using constructs like while, for, loop, etc. we can design an algorithm. And the third part would be to write it in a problem solving methods. For example, any programming languages I can use, and then I could decide on an algorithm and decide its base. The third one would be the flowchart. So flowchart is nothing but a pictorial representation of an algorithm. So these are the 3 steps in algorithm design techniques. Now the next fourth stage would be proving correctness. So proving correctness can be done by 2 ways. So correctness can be done by verification state and by validation stage. The fifth step would be analyzing the algorithm. So analyzing the algorithm includes several parts such as time complexity. We know time complexity is nothing but time complexity is defined as the number of steps executed for its basic operation. Then we could decide on space complexity, the amount of space required for an algorithm to store its variables. Then the simplicity could be analyzed. The generality of the algorithm also could be analyzed in this stage 5. The final step or the final stage in analyzing an algorithm design is to code an algorithm. We have to find the suitable means of programming language, and also we have to write the optimized code for writing the language. So these are the 6 different steps in algorithm design and analysis process. Let us again see one by one. So the first step is understanding the problem. Then it is a decision making. Decision making can be of 3 types: to see what is the computational need, exact versus approximate solving, and algorithm design technique. The third step would be designing an algorithm, followed by proving the correctness, and then efficiency of an algorithm is analyzed, and finally the coding of the algorithm is